The transistor functions as a switch or gate for electronic signals, opening and closing electronic gates multiple times per second. Transistors ensure that an electronic circuit is on when current flows and off when it does not. The complex switching circuits that form all modern networking and telecommunication systems rely on transistors. These circuits also offer high switching speeds, such as hundreds of gigahertz or over 100 billion on-off cycles per second. Transistors are combined to form logic gates, which compare multiple input signals to produce different outputs. Computers with logic gates can make simple decisions using Boolean algebra. These techniques are the foundation of modern computation and computer programs. Transistors also play a crucial role in amplifying electronic signals. For example, in radio applications such as FM receivers, where the received electrical signal is weak due to interference, amplification produces an audible output. Transistors increase the signal strength to provide this amplification. Transistor component. A transistor is similar to a pair of diodes, with either the cathode or anode connected together. It has three terminals that allow electric current to flow and facilitate connections to an external circuit. Emitter, the negative terminal of the transistor. Base, the terminal that activates the transistor. Collector, the positive terminal of the transistor. An NPN transistor has a p-type silicon base. This base is sandwiched between two layers of n-type silicon, which are the emitter and collector. The emitter is moderately sized and heavily doped. Its main function is to supply electrons, known as majority carriers, that carry most of the electric current. It is called the emitter because it emits electrons. The base is the central terminal between the emitter and collector. It is thin and lightly doped. Its primary purpose is to channel charge carriers from the emitter to the collector. The collector gathers charge carriers sent by the emitter through the base. The collector is moderately doped and larger than the emitter and base. The emitter, base, and collector have the same functions in a PNP circuit. The only difference in a PNP transistor is that an N-type base layer is placed between the P-type emitter and collector. The NPN versus PNP configuration determines the direction of the emitter arrow, which is always part of the emitter-base junction. The arrow points outward for an NPN circuit and inward for a PNP circuit. Logic gates are the basic building blocks of digital circuits, performing fundamental operations on one or more binary inputs to produce a single output. 1. NOT gate. Function. Inverts the input signal. If the input is 1, true, the output is 0, false, and vice versa. Symbol. A triangle pointing to the right with a small circle at the tip. Truth table. Input, 0 output, 1. Input, 1 output, 0. 2. And gate. Function. Produces an output of 1 only if both inputs are 1. If either input is 0, the output is 0. Symbol. A flat-ended shape with 2 inputs on the left and 1 output on the right. Truth table. Input, 0, 0 output, 0. Input, 0, 1 output, 0. Input, 1, 0 output, 0. Input, 1, 1 output, 1. 3. Or gate. Function. Produces an output of 1 if at least one of the inputs is 1. It only outputs 0 if both inputs are 0. Symbol. A curved shape that narrows to a point on the right. Truth table. Input, 0, 0 output, 0. Input, 0, 1 output, 1. Input, 1, 0 output, 1. Input, 1, 1 output, 1. These gates are used in various combinations to perform complex logical operations in digital electronics.